In this video, we're going to look at numbers 7 through 13, which is this application problem. So a sailboat is passing through a canal and approaching a parabolic bridge. The shape of the bridge can be modeled by this equation. All units are represented in meters. To find the width of the bridge from end to end, what important point or points on the parabola are needed? So let's first look at what this situation would look like. So we have a sailboat. So here's the sailboat. It's passing through a canal, which is a body of water, and it passes under or approaches a parabolic bridge. So it's going under this bridge. So we're trying to find the width of the bridge, so this distance from here to here. What important points on the parabola are needed? Well, these points are the roots or the x-intercepts of the parabola. What method would be most appropriate in order to find those points? So we know a couple methods of solving quadratic equations. If we're finding the roots, we're finding what x is equal to when y equals 0. To make this a little bit easier to deal with, we could try to get rid of these decimals by multiplying everything by 10. And then we can try factoring it, but if you try factoring it, 56 and 32 do not have any numbers that multiply to 56 and add to 32. So that's not going to end up working. So then we can use the quadratic formula to solve it. So if we plug everything into the quadratic formula, A equals -1, B equals 32, and C equals -56. We can solve for the roots. So negative b plus or minus the square root of b squared minus 4ac over 2a. So simplifying that, negative 32 plus or minus the square root of, if we type all of this into a calculator, we're going to get 800 and then divided by -2. So since this is a real life application problem, we might as well change this to decimal form instead of leaving it in radical form so that we get a better idea of how far apart these x-intercepts are. So if we just type that into a calculator, negative 32 plus the square root of 800 divided by -2, that's going to be one root at 1.86. The other root would be negative 32 minus the square root of 800 divided by -2, which is 30.14. So on my diagram here, I know that 1.86 is one of the roots and 30.14 is another root. And if I'm finding the width of the bridge, we would just subtract those from each other. So 30.14 minus 1.86 is 28.28 meters. Number 10 is asking if the sailboat's mast reaches a height of 25 feet above the water, so this is a height of 25 feet, what important point or points on the parabola would be needed to determine whether the sailboat will fit under the bridge? So if the sailboat needs to fit under the bridge, we need to figure out whether it's going to hit the top. The highest point is called the vertex. So in this case, the vertex is the important point we would need to try to find. So let's see if we can actually find where that is, and then we'll be able to answer this question. The formula to find the vertex of a parabola is for the x value. So the x value of the vertex is negative b over 2a. So going back to our original equation, negative 3.2 over 2 times negative 0.1. So negative 3.2 divided by 2 times negative 0.1 is 16. So that's the x value of the vertex. Now the height here is going to be the y value of the vertex. So if I plug everything back in to the original equation, let's type that all into the calculator. So negative 0.1 times 16 squared, okay, plus 3.2 times 16 minus 5.6 equals 20. So this is 20 meters high. So this vertex is at 1620, however the sailboat reaches a height of 25 feet. So no, the sailboat will not fit because the height of the bridge is less than the height of the sailboat. Write the bridge's equation in graphing form. So graphing form is y equals a x minus h squared plus k. A is going to stay negative 0.1, x minus 16 squared plus 20. Make a complete sketch of the bridge. This is what we want, and you can transfer it to this xy axis, where this is the 0, 0 point.